These are the quotient and product formulas of complex numbers in polar form. Now, I'm not going to spend much time, well, actually, I'm not going to spend any time using these formulas because, again, this is a situation where, since the style of education as of 2013 is still a very medieval and kind of antiquated style, so a lot of time is spent on these formulas that serve absolutely no purpose, really. And multiplying and dividing complex numbers, or any numbers really, are all going to be done by computers now. So to be learning how to be spending time punching in numbers into a formula that are going to be punched out by a computer anyways, it's just not a very good use of the time. However, that being said, what is useful is kind of just breaking down these different formulas and seeing where they come from and how how people have basically used ideas from other parts of math to kind of bring stuff together. So I think spending time just to see how one gets the formula is the only really useful thing out of this. But this book goes on forever and ever practicing putting numbers into a calculator. So it's not very important. So I'm not going to spend any time doing that. What I am going to spend the time to do is, like I said, just to see where these formulas came from and how would I get these formulas. Not that it's important, it's just good just practice just to apply what I would have already learned from previous sections to things happening now. So I've got the standard form of a complex number in polar coordinates, and I want to come up with this formula. So say if I didn't know this formula at all, or this formula, how would I go about doing that? Well, I would start with this regular form, and then I'm going to be multiplying two complex numbers together. So I'm going to have a z1 and a z2. So it will look like this. Times z2. So let me just write it in a very simple way first. So I have the radius 1 cosine theta 1 plus I sine theta 1, which are all from the first complex number. And then it's going to be multiplied by the second one. So one thing I can do is just take out the R1 and R2 pretty easily. And then what I'm going to do is use the FOIL method, cosine theta 1 times cosine theta 2, cosine theta 1 times I sine theta 2, I sine theta 1 times cosine theta 2, and so on. So what do I get? I'll get, this is equal to, let's take out the R1 and R2. So cosine theta 1 cosine theta 2. It's not cosine squared because these are different angles. It's important to remember that. So what's the next term? Plus I cosine theta 1 sine theta 2 plus I sine theta 1 cosine theta 2, and this is going to be a minus because I'm going to have I sine theta 1 times I sine theta 2 with the I times the I squared is equal to minus 1, so this will turn into a minus sign and the I will disappear. barely fit it in there, but I got it. Okay. So now what I'm going to do is arrange these terms together. I'll put the i's together so I can factor that out, just kind of simplify it. So R1, R2 still there. Cosine theta 1, cosine theta 2. And then it's going to be a plus. I will be just factored out. The reason I'm arranging them this way will be apparent in just one moment. So I'll rearrange this, and this may look familiar, may not look familiar, but this should definitely look familiar because it is one of the trigonomic identities that I learned earlier, so it'll be a way for me to simplify. Oops. So if I go all the way back to, I don't remember how long ago it was, but a while ago, I remember I did a bunch of formulas for the addition of two angles, and one of them was cosine alpha plus beta is equal to cosine alpha cosine beta and there are two. I mean, it really just depends on, I mean, they're all very similar, so it's very easy to confuse. That's why in general no one memorizes these, because it's dumb too. I mean, you can go around and derive them. What I usually do is just remember one, and then I just derive the rest. But I could also just derive it from the graph. Remember, I'm not even going to go into that. There's no point. But here's one for cosine alpha beta, and then there's also sine alpha beta. And that is equal to sine alpha cosine beta plus cosine alpha sine beta. Now if I go back up here, alpha, I mean, these are two different angles, so if I look here, alpha and beta, theta 1, theta 2, whatever, it's the same idea. So I can interchange this with this, and same thing with this over here. So Z1 times Z2 is equal to R1 times R2. Now I'm replacing this term, cosine theta 1, cosine theta 2, cosine alpha, cosine beta, minus sine theta 1, sine theta 2, sine alpha beta. So this interchanges with that, so I can just put in cosine, well, in this case I have alpha, or theta 1 plus theta 2 instead of alpha plus beta, but I could have done it the other way as well. It doesn't matter. I could put whatever I want in there. And then this second term I can change out with sine alpha plus beta, or sine theta 1 plus theta 2, but the only difference is going to have this I that's out in front of it. So plus I sine theta 1 plus theta 2. So that's the product formula. Let's go up and check. Yep, it's the exact same one. So that's how to get that one. So this next one looks like it should be pretty easy, and it is, but I've got to admit, when I was first doing this, I did the first one, no problem. Then the second one, I blanked out on it for like 20 minutes. I got to where I needed to go, and then I just stood there like an idiot. I just had like a total simple jack moment on it, but I'll show you where that was. So if I want to do division, I mean, just looking at it, you should know that it should be easy. But then I was like, I couldn't. Well, whatever. I'm gonna go on there. But it was really terrible. It was an embarrassment to math. So Z1, Z2. Well, actually, I don't really need to rewrite that out. But anyways, it's what have I got here? So I got R1. Cosine theta 1. So I got here, and then I was like, well, obviously I can factor out the R1 and R2, so let's do that real quick. I'm just doing it just to show why I had such a stupid moment. So I got to here, and it's just going to be really funny. I mean, I got to here, and I was like, okay, well, now I just need to simplify the denominator. And for some reason, I just missed the complete obvious. I was sitting here, and I was trying to, I just didn't know, I hadn't done anything. I hadn't done this for a while, so I was sitting here, and I was like, oh, crap, well, yeah, let's just, multiply by the inverse. So I had some, I don't even want to put it on there, but I had some crazy on there. I had, 2 plus, cotangent squared plus squared theta 2 plus cotangent squared theta 2, and then a bunch of weird stuff on the top. And eventually I was like, alright, this obviously is not the way to do it. And I sat there thinking for 20 minutes, and I just couldn't think of it. I was getting really mad. And then all of a sudden it just clicked. I was just like, duh, I gotta multiply it by the conjugate. So I'll multiply, but man, I felt really stupid. Like I said, it was a complete simple jack moment. So you just multiply by the conjugate, and then what's going to happen is the middle terms will cancel out. I knew I had the right idea. I was trying to get the bottom to equal 1, so it would just get it away, but for whatever reason, I just couldn't think of the conjugate for whatever reason. But, yeah, multiply both top and bottom by the conjugate of the bottom. I mean, it was so obvious after I did it, but man, I just felt like a dumbass. So yeah, I got that. Then what's going to happen is, see when you multiply by the conjugate, you're not going to get a whole bunch of weird middle terms with I and cosine I. So if I didn't multiply by the conjugate, then in the middle term, well, I would get cosine squared theta 2, theta 2 plus 2i cosine theta 2 sine theta 2, and then I would get minus, oh, this is an I, my bad, forgot about that, and then I would get minus sine theta 2, which would cancel out to be minus 1. So that was one of the other things I did. For whatever reason, I just didn't think of the conjugate. I did the positive first, and then I got the minus 1 in the bottom, and then I had that weird term, the 2i cosine theta 2 whatever, and then I tried doing something different and it just didn't work out. But what this is going to do is I'm not going to get that middle term, and then this is going to turn into 1. So let's just watch what happens. I mean, it seems so obvious now, but I mean, it is really obvious. It was pretty inexcusable, but I could definitely see a lot of people just forget. I mean, sometimes you just don't deal with complex numbers that much. You just forget about the conjugate anyways. So let's just multiply this out, FOIL it. So I got, on the top, I'll get cosine alpha 1, Oh yeah, and can't forget about the R1, R2. Cosine theta 2, what's next? Yeah. Is that minus? Yeah, it is minus. So minus I cosine 1 sine 2 plus I sine 1 cosine 2, and then this is minus sine, so I'm going to have minus sine times positive sine, but the i's are going to cancel out, so it'll become positive. So plus sine 1 sine 2. So that's the top. And then the bottom, which is the important part, I get cosine. Well, let me just multiply the whole thing out, so it just becomes very obvious why I'm so dumb. So cosine squared theta 2, and then minus, oh, I knew it. And I paused because I remembered the I, and then I didn't put it there. Cosine 2 sine 2, next plus I cosine 2 sine 2, and then last, again, I get minus, well, I get a minus sine, I get minus sine, but the i's are going to multiply and be minus 1, so it's going to change it to positive. So sine squared theta 2. And like I said, the first time I put a positive there, I don't know, I was just being dumb. And I got 2 of these, not, both of these were positive, so I had 2i, so that's what I was talking about, the 2i cosine theta 2, and then the sine theta 2, and then I had a minus 1 in there as well because I didn't have the minus sign. So I just got weird stuff, and I was just making things more complicated than they need to be, and I was being dumb. So don't be dumb like me. So anyways, these are going to cancel out, and another trigonomic identity that is, well, that's really easy to remember, is sine squared theta plus cosine squared theta is equal to 1. So I use this, cosine squared, sine squared, so these I can replace, I can use these with this, which is equal to 1, so basically this entire denominator is going to drop out. So that is where I was having problems like an idiot, so I did that. And then I'm going to do the same thing I just did last time, sort out the terms with the I, put them together so I can factor that thing out. So R1, R2, and now I don't have a denominator, which is awesome. Nobody likes those. And also I, and then I factor out this. Let's reverse the order. And again, I'm going to use those formulas, but I'm going to use the subtraction ones this time. So, where's my handy formulas that I wrote down? I mean, I already know what they are, so I mean, no, I'm looking. Just go to the top. So cosine alpha minus beta equal to cosine alpha cosine beta. Hold on, did I make a mistake? Yeah, I did make a mistake. Where's it should be a minus. Cosine alpha cosine. Sine I. No, I didn't make a mistake. Oh. So that's 1 sine alpha minus beta is equal to sine alpha cosine. Oh. Putting the wrong symbols in there. No, I had to have made a mistake. What the hell is this doing here then? Hold on a second. Ah, this is a plus sign. There we go. Solved it, because this is definitely a minus sign. Yeah, this is a minus sign, so yeah. Where's the... Yeah. Alpha plus beta is a minus sign. Yeah, see, this is why you don't memorize these things, because they're so freaking similar. Yeah. See, I made a dumb thing. I mean, I didn't want to waste everyone's time by deriving all of these myself, but yeah, see, you don't ever want to memorize garbage like this, and I don't see why anyone would make you memorize garbage like this, because that's just a dumb mistake, and what are you going to do? I mean, but anyways, let's go back to here. So just replace this with that, or more like this with that, and this with this over here. And I get z1 over z2 is equal to r1, r2 cosine theta 1 minus theta 2 plus, and then there's going to be the I sine theta 1 minus theta 2. And that is all there is to it. And that's another, like I said, it's really easy to make a mistake if you just go around memorizing these things. I wrote them down, and I wrote one down wrong by accident, so it just goes to show you that it's easier just to use the graph the graph method, like and then you have two different lines, and then you have cosine 1, cosine 2, cosine 1, this, cosine 1, sine 1, or whatever, and then you do the subtraction. If not, go back to that video where you can, and then you can get the rest from there. So I never bothered to memorize them, but like I said, it's just something to be very careful with in doing all of these problems. Actually, May as well just leave this in here. I was considering just to redo it, but it's good to see that the kind of mistakes that someone can easily make, and it's not that they don't know how to do it or anything like that. It's just the way it is. It's a lot of information, so I wouldn't recommend memorizing any of them. Just use a sheet, and even then, double check that sheet, make sure all those formulas are right, and just understand where those formulas come from. And like I said, I wouldn't I wouldn't really spend much time actually using this formula, because all you do is just put in some numbers, and it doesn't exactly take a high genius to do that.